Hey guys, it's Thursday, June 7, 2012. I'm John, aka Jab, and this video is about total power draw with Intel versus AMD CPUs. And Intel recently admitted that they have to increase the total power draw up to like 160 watts. Now the typical maximum total power draw is 130 watts on an Intel CPU, 125 on an AMD CPU. And you'll see lower ones like 95 watts or 65 or even 45 watts on AMD models, or 75 watts on Intel CPU models. So why 160 watts? Also, where are the 6 and 8 core consumer CPUs that don't cost $600? I mean, there's a lot of perspective that needs to be added here. So when I see articles titled, and I didn't read the article, but when I see an article titled, quote, "Is AMD still relevant?" end quote, by Brooke Crothers over at CNET, and no, I'm not going to give him the benefit of linking to it, so if you really want to read that kind of garbage, you can read it. Brooke Crothers, leave the internet and don't come back, because that is an example of someone who is going to write an article in which they have no understanding of what they are talking about, people. Alright? AMD has, at the 32 nanometer process, and keep in mind, for those of you who are not quite as up on this as, obviously, me, because I'm the one doing the video, the nanometer process is how thick the wall is, measured in nanometers, which is closely correlated to atoms, but not directly, and the smaller the CPU wall, the more efficient the process is, and thus the less power it requires to get the same amount of performance. So the smaller the CPU die, the better, or the process node, whatnot. So full node, an example, you'll go from 32 to 28 nanometer, where a half node, which are generally half steps that are taken in between, are used. Full nodes are used by CPUs. Half nodes are traditionally used by GPUs, video cards. So 45 nanometer down to 32, down to 2022. Again, smaller is better for the CPUs, whereas they had, I think it was, I can't remember what it was before that, but they had 40 nanometer and then 28 nanometer for the video cards. 28 nanometer coming out, being out fresh for 2012. So, total power draw and CPU core count. AMD at 32 nanometers has 16 core server CPUs. Intel at 22 nanometers, which they have had 22 nanometers for roughly a year now, I think, because they have their own manufacturing process, which is separate from pretty much everyone else as far as I can tell. They have had only until just very, very recently, so recent that there still aren't CPU pictures on Newegg, and I go into the moment, have only debuted with 8 core server CPUs. Now, server CPUs are generally where a lot of the R&D goes, and it trickles down to the consumer CPUs, where most of us will be buying stuff for our gaming rigs and so forth, or local production. Not, more like you're at work or you're building your own business, not like you're at like a data farm or whatever, your server center or whatever. So anyway, so Intel only just recently actually released 10 core server CPUs at the 22 nanometer process. Now think about that. Not only when the process shrinks does the performance increase, but you're able to actually physically put more cores in the same amount of space. Like if the CPU, like actual size of the CPU doesn't actually change when the process itself does. Okay? When I'm doing this, I'm talking about the CPU package, the actual physical CPU that you hold in your hand. So why is Intel stuck at absolute best 10 cores at a lower and thus better process than AMD? And not only that, but considerably less CPU cores. Well, one of the things that I've noticed Alright, and don't get me wrong. Everyone has to admit that Intel's per core CPU performance is better than AMD. Alright, but there's a catch here. Intel's approach to how they basically do everything is so fanatical about CPU performance that they basically, I'll give you an example. When they decided they wanted to compete with ATI and NVIDIA years ago, and they were trying to produce a video card, while they were able to produce something half decent and kind of actually demonstrate it, and not by playing a YouTube video and trying to show it off, or a VLC video and show it off as a live demo, but actually demoing it in a very controlled environment, but still demoing an actual product, they weren't able to get the performance of ATI and NVIDIA that they could put in a marketable product out on the market where you and I could buy it. What happened? They kept trying to make the video card into a multi-threaded, massively threaded CPU. And we all know that most people who are at least half well read up on tech know that a CPU core does things a lot differently than a GPU core. So certain things are a lot better processed through a GPU than a CPU, and vice versa. So they both have their strengths and their weaknesses. So going back to the total power draw, Intel recently admitted that their upcoming generations of CPUs will use very high TDPs, upwards of 160 watts, where the maximum total power draw is typically 130 watts, absolute maximum, with the very rare 150 watt CPU, and whereas AMD's maximum total power draw is typically 125 watts, or on rare occasion they'll go up to 140. So if you go on Newegg, you can generally go to the CPUs and go to the consumer ones that are labeled as desktop CPUs versus servers, and they'll generally list the total power draw in watts, which would be abbreviated as W. So that's what TDP is, for those who are wondering what I'm saying when I say TDP. So basically what Intel has been doing has basically been taking the per core performance and trying to just push all that multi-threading through a limited number of cores. And while it does work to an extent, what they've ended up doing is shooting themselves in the foot, because one of the big issues with core count is actually having every single core being able to communicate effectively with all those other cores. This is where all the marketing BS gets thrown out the door, and we look at the actual quality of the CPU. Yeah, you could make a single core run faster with Intel than AMD. No doubt about that. What happens if you do 180 miles an hour around a 90-degree turn that's only, say, 500 feet in length to finish doing the actual turn with your vehicle? You're going to have some trouble without having to slow down and, say, run into a tree if there's not like massive amounts of paving and or laws to prevent you from going 180 miles an hour over a 90-degree turn. That's basically what they've encountered, because they're using so much CPU, they're using so much electrical power per core that when they're trying to force all this computational power through each core, they've now realized that they're not able to keep the power within a reasonable limit. Why do you think it costs $600 for the absolute cheapest 6-core consumer CPU from Intel? And it's on their high-end platform, the Socket 2011. Alright? The reason for that is because it costs them a lot of money. It costs them a lot of money. And they're not going to pass the savings down to you guys, they're going to charge you for it. And it's mainly to say that yes, we can do it, but they're not actively admitting that their ability to have those cores all communicate effectively has now led to them realizing that the total power draw per core is so astronomically high that they've traded off power for performance. Some people don't care about total power draw. I do. An example, I got rid of my 8800 GT because it was getting kind of hot at 220 degrees or 160 degrees at high loads. That kind of makes your room kind of hot if you're living in a 10 by 10 foot room like I do. Okay. Whereas when I went to my 5770, at load, it'll hit 160 degrees Fahrenheit, and at idle, it'll be around 125 degrees to 120 down to, about 120 degrees Fahrenheit. Much cooler, much more manageable, doesn't have as much effect, and also draws a lot less power for that part. So not only do we save electricity, but it generates less heat, which is obviously what we want, is less heat, especially when you live in Florida. And by the way, I'm not a native. So anyone who's visited the state knows what I'm talking about, because you've left as quickly as possible if you're on the intellectual side. Well, maybe some people like it, but yeah. So anyway, back on topic. So, the CPU core count. So, this explains why Intel only just now brought out their 10 core CPUs. Now you got to keep in mind that the manufacturing process also has to be refined. So an example, while they've had 22, Intel has had 22 nanometers because they have their own manufacturing plants. They've had to refine the process. So only until recently have they been able to refine the process that they've been able to fit 10 cores on there and keep the power to a reasonable level. And keep in mind that for servers, when you have tens of thousands of CPUs, you've got to cool tens of thousands of CPUs in a data center. Data centers and people who run them want more cores and less power overall. So if you go on Newegg and you start looking at the total power draw, the core count, and the correlation of that, you're going to notice that AMD divide the total power draw by the number of cores. That's going to give you a general idea of how much power each core is drawing. So if I go on here and I do the math really quickly for you guys, alright, so let's look at Intel's 10 core. Alright, they have, it says here 130 watts. So we take 130 divided by 10, that's 13 watts per core. Alright, let's go to a 16 core. We're comparing core count, the max core count versus the total power draw. So that's 13 watts for 10 core per core at 22 nanometers. AMD, we have 115 watts. So we take 115 watts and we divide it by 16. We have 7.1 watts. So that's 7.1 watts per core, 16 core. Now, what does that tell you when AMD uses 7.1 watts on an older 32 nanometer fabrication per core than Intel at 13 watts on a 10 core CPU at a better, smaller fabrication at 22 nanometers? Well, it tells you that Intel prefers power and performance over basically the ability to process things and design their CPUs in a way that are more forward-thinking. Because you've got to remember, AMD has been the one who has been first with a lot quite a lot of things, actually. They're first to hit 1 gigahertz. They were first to bring out 64-bit computing. I think they were first to integrate this memory controller into the CPU, increasing performance in that regard. And there are a whole lot of other things. Just basically read any AMD fanboys, AMD's first kind of post. And yeah, now that gives you an idea of the design mentality, including with their old attempt to make the video card with etc. And it ended up becoming a PCI Express card with like 100 CPU cores that are marketed towards like scientists and stuff, that was originally intended to be a video card to compete with, at the time, ATI and NVIDIA. So that is generally my take to address these really lowbrow attempts where people are like, oh, why is AMD even bothering? AMD's architecture, AMD's approach to CPUs, to building a CPU, is actually superior, because in the long run they have to actually have to keep building upon what they already have. This is the exact same thing with what I'm doing with my software and my business, because if I did the quick approach, like an example using jQuery, which is an absolute disaster performance-wise compared to, say, native browser rendering of pretty much any and everything, in the long term, especially if you're like on a mobile device and whatnot, you're going to have to download all that bandwidth, mobile, dial-up, etc. And quite a lot of people actually are on that. And by not plopping 70 kilobytes, or the minified version 30 kilobytes, which doesn't sound a lot if you're on broadband, but you got to keep in mind that the browser still has to render this, and browsers are still single-threaded pieces of software. So they're still going to only be able to use one CPU core, regardless of whether they're Intel or AMD. It's going to have to basically, you might have 4 cores, you might have 8 cores, you might have 10 or 16 cores. Alright? Who knows? You might be watching this video 5 or 10 years later and we have 100 CPU cores. But with the browsers, well, likely for a long time, or at least years, for a while now, for years to come, still be single-threaded. And how the software is written, if it's not able to utilize multiple cores, right, versus other multiple cores. Now, that's just one look at how badly coded software in regards to jQuery, not necessarily the browsers, because the browsers are legitimately complex to be single-threaded, except for the out-of-process, the plugins and whatnot, which are in all the browsers at this point, as far as I can tell. Then you have virtualization, because I test newer browsers in virtualized copies of Windows 7 and Windows 8 for Internet Explorer 10, just to check it out, while my production operating system is Windows XP. And yes, some people are like, why are you still using Windows XP? That's so old and irrelevant. Software does not become irrelevant because a newer version is released. Software becomes irrelevant when it is no longer useful to the people who are using it. So an example, my file manager, Windows Explorer in XP, is customizable. The buttons don't start moving around when you go to different folders like in Windows Vista 7. And they're not a huge, like, 5 dead bodies taped together like in Diablo, like some kind of monster where you don't know if you're actually over one button or another, etc. So the ability to use software comfortably is what makes software relevant, regardless of how old it is. People have used their computers for 20 years, the exact same computer to do writing documents and whatnot. If it does the job, it does the job. There are computers that are in mines that probably have 286, Intel CPUs from the 1980s, still working. They do the job. They do the job. Same thing with software, no different. So with multi-threading, getting back to that, when I load up VirtualBox, an example, and there's other software that will allow me to emulate other operating systems on top of XP, such as Windows 7 and Windows 8, the abomination that looks just like AOL back in 1996, and I can choose how many CPU cores that I can allocate to that given operating system, including but not limited to Windows, as I also virtualize Linux to test out things like Conqueror, or just trying to find a decent Linux distribution that's actually customizable, and not, example, following a fad that's following a fad and taking a desktop computer and making it into a tablet toy. So, in conclusion, when we look at everything from a user's perspective, as a developer building his own business, I need more cores. Yes, in some cases, per core CPU performance is important to me. I will not say in any case that it's not. However, I will say it is less relevant than core count. And as software, which is the ultimate deciding factor in its ability to utilize the CPU architecture, an example, the bulldozer architecture, software dictates whether you think bulldozer sucks or not. An example, if the software is built correctly, bulldozer CPUs are built explicitly, when supported by the software, to take a single process that is single-threaded and to treat a bulldozer unit, which comprises 2 CPU cores, and to treat those 2 separate CPU cores with their shared resources and actually emulate sticking 2 CPU cores together. And so the software that is single-threaded, in an example, could theoretically double the performance by using the bulldozer architecture for a single bulldozer unit, whatever they call it. And each unit is comprised of 2 actual physical cores that share resources. So while no, you don't get 4 gigahertz from a dual core 2 gigahertz, you do effectively when the software is written to take advantage of bulldozer, that kind of improvement in the processing power. That is what people don't understand. That is how bulldozer shines. That was the grand design. You don't get that with Intel. You can't take a piece of software and rewrite it for an Intel CPU to take 2 cores and use them like as if they were a single core to double the performance. That does not exist on Intel, or at least not at the time that I'm shooting this video. AMD, you can't. It is the user's perspective that bulldozer sucks. It is not that bulldozer sucks. Yes, again, the per core performance is not as brute force as Intel, but the long-term perspective, which matters, especially as a business, someone building his own business, the quality of the code that I use to build my business is absolutely necessary to be reliable in the long term. So an example, when a user needs to use a feature, I'm not babying a user to do something simple like changing the style of a text or uploading an image. I'm building a new feature to increase the ability for my business to bring in more customers by appealing to having more features instead of not building the software right the first time. It's about long-term planning. AMD has it, Intel obviously doesn't. And that, again, is because they admitted that they have to go up to 160 watts instead of 130. And we can see that because they brute forced with their CPU performance instead of building a better design with how they use the energy, the electricity they have running per core, and the communication between every single core. Because remember, the more cores, the more sophisticated, because those cores in the 16-core CPU, Opteron CPU at 32 nanometers have to be able to communicate with every single other core. Do the math. Again, 13 watts per core on Intel, 7.1 on AMD. AMD process, you can combine 2 CPU cores, treat them as a single core if your software is written. If your benchmark realizes if the software is written that way. If your review or your blatant article that goes out and says, oh, is AMD still relevant, blah, 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 blah. People who don't know what they're talking about should leave the internet. Thank you for watching, guys. I'll see you guys around. Where's that window? I've got so many things open on my multitasking quad core.